Good afternoon, everyone. Good afternoon. Hello, everyone. Students, are you there? Voice clear? Voice clear? Am I audible? Good afternoon. Yes, yes. Okay, now messages are there. Swati, good afternoon. Ananya, good afternoon. Manish, Sajid, good afternoon. Very good afternoon. Hari Surya, very good afternoon. I hope you people are doing well. And what about the exam? PACE exam, space exam? How it was? Have you gone through the paper after the exam? Have you gone through the paper or have you done the paper analysis? Good afternoon, Saiti. Very good, Swati. Very good, Manish. So, what's the score you people are getting? Manish, Swati, those who are names are given. Sajid, very good, 165. Manish, 151, 148, 156. Okay. The online is not there here. Space not there. Pace is there. In PACE, name is not there, yes, only enrollment code is there. Okay, fine. Good morning, good morning, good afternoon, good afternoon. Okay, students, so how was the exam? Have you gone through it? After the exam, we have gone through what are the mistakes you are doing. Are you able to analyze those mistakes? Maintain a notebook for the paper analysis where you can write the remarks, why you are getting wrong in particular question. Yeah, it is very important. Otherwise, though, time will pass. So many exams will be there. Tell CO, CO2. Okay. Okay, students. So shall I start? One question is asked by Saini about the bond angle comparison. So quickly go through it, Saini, and you can see there are different types. Blessy, good afternoon. Very good afternoon. See, it is simply here the bond angle you cannot take. Two atoms are there. No use of bond angle. You can use bond angle for which one? It is 180. It is 120. This is not appropriately you can place here because between two atoms, how can we say bond order? ठीक है ना? Between two bonds, we can say the bond angle. Getting it, Saini? Any other student? Any doubts you have in the yesterday's paper? In my track? You want to ask any question from that? Okay, Saini, bond length, very easy now. Bond order is there. Apply the concept of bond order. 3, 2, and it is 4, 1.33. We have done this question, I think, in the resonance. Yes or no? In resonance, I have done the bond order we can find for carbonate. It is 4 by 3. Or you can find by normal also. Here double and single bond is there. Here purely double bond is there. Here it is triple bond. More bond order, less will be the bond length. Any other question you want to ask? Yesterday's paper, PACE exam. Or shall I continue with the resonance concept? What was the exact last part? बोलो भाई कैसा रहा पेपर. पॉइंट इज दैट कि मार्क्स तो लिस्ट वी आर गेटिंग, सम इज 140 150. No, bond angle we will not relate with bond length. Seni, no, bond angle we are not going to relate with bond length, we relate with bond order mainly. Yes, bond order inversely proportional to bond length. Those who are getting 150, okay, fine, 140, fine. But students, you are at home, understand one thing. Now, at least in PACE exam or space exam, try your best now. You're getting 140, 130 like this, then total score will be affected. So you have to seriously work. At home, you have to seriously plan your schedule that I have to revise the concepts, I have to recall them multiple times. And before the exam, I have revised that syllabus 5 to 7 times, 10 times I have revised properly. It's up to you that how maximize the recalling of that syllabus. Otherwise, so 130, 140, that will be a tough fight na, later on. Right now, you can plan the things. Getting it, that you have to plan it out. Otherwise, there कोई benefit ही नहीं है ना. There is no benefit like you are attending at home and everything is there. You are enriched with the resources. Everything you are getting at home, still you are not able to score the marks. Why? Come to the campus, go for the offline mode, see the students, experience the competition there. Then you might feel the heat that yes, yeah, I have to work. Otherwise, so at home maybe a lot of students they are getting in a easy mode. They are easy going mode. Am I right or not? We are try up above 600. Try first. Those who are getting 650 above, they try up to their level best 680 above. Like this in PACE exam, so you can. But ultimately, last exam you have to see na. You are scoring. Suppose you are scoring around 550. Set the mark that I will next time try at my best 580, 590 like this. Suharsita, yes. Good afternoon, beta. So every one of you take it in a positive way that yeah, why I'm not getting the marks in particular topic or subject, then you have to work on it. It's not about only these many marks, 500, 550, 600. If you are getting 600 every time, try your best, not 620, 630, try at your level best. Point is, keep on working in a planned way. If you are not working, what will happen? With time, that score will be difficult for you to attain the same score. Every subject go through it several times before the test. Revise it, recall it, revise it, recall it, write it down wherever getting stuck. ठीक है. It depends na Seni, if you are getting how much marks. Suppose you are getting 120, it should be above 140. If you are getting 150, above 170, 160 or 165. If you are getting 170, always set the target 175 or 180. I'll set. It depends upon you. But minimum I will say 140 above, 150 above should be there in chemistry, 150 above. But it depends upon your where you are standing in the earlier test. ठीक है. So anything we want to ask? Otherwise, I'll start with the resonance. Indra Karan saying that the papers. Okay, let me ask. In WhatsApp group, paper should be sent na. Tell him. हाँ. ठीक है, स्टार्ट करते हैं. तो लास्ट क्लास में we have done what resonance we are doing. Yes. In resonance, which thing we have discussed in resonance? In resonance, we have discussed up to which part? In NCRT, I think reading part we have done. Some points also we have discussed, right? CO2 structure, bond order, done a bond order completed. Bond order completed, bond order, bond length comparison. That exactly last part was which example? I think CO3 2 minus. ठीक है. So we have discussed the NCRT example and benzene example. ठीक है ना? That we have done in last class. We have done the wait, I'll exactly see where I have stopped. Okay, O2, O3 example was done. O2, O3. ठीक है. That example I have stopped here. It is O2, O3 example. So that is. ठीक है ना? Try any questions from yours? ठीक है, चलो. The last example was O2 and O3. Any questions you want to ask? Last class example. Any questions from your side up to last class example? O2, O3 or CO3 acetate ion also is there. We can talk about CS3, COO minus. We can talk about that. Any questions up to last class? Any questions? Nahi? Okay, so this example we have done acetate ion or not? Acetate ion is also resonance stabilized. How? Negative charge, sigma bond, pi bond. If you remember, 2-3 types only we have written. Negative sigma pi or pi sigma pi or pi sigma lone pair. ठीक है? Theoretical points we have discussed or not? Theoretical points of NCRT we have discussed. Theoretical points of NCRT, like which one? Which are given as some misconceptions given. These points discussed or not? Some misconceptions. I think it is also completed. Yes. ठीक है. So in the resonance we have discussed few examples, then bond order also we can find for them. Here bond order of carbon oxygen. How much bond order? 3/2, that is 1.5. Clear? That is which example last class we have done. Either write the two structures or simply find the resonance is taking place here. How many total bonds? 3. How many sigma bonds? 2. 3/2. ठीक है? Other example, if I say we have done PO4 3 minus or not? If done, then do not try it, or you can write other if you want. Otherwise, this one. SO4 2 minus. Bond order of PO bond of PO, and other is bond order of SO bond. What's the bond order of PO in the case of PO4 3 minus? Structure is this one. If you remember, it is AB4 type structure. PO4 3 minus, I forgot it is 3 minus. 1 2 3 आ गया. Bond order will be how many total bonds? 5. And sigma bonds 4. Answer is 1.25. Very good. Yes, Kavita correct. Manish correct. 5/4 correct. Vagdevi correct. Shravan Kumar, yes, very good. What about next one? Sulfate. Sulfate ion में Sukanya completely, yes, 1.25, very good. 1 point, Dal, हाँ Kavita, 1.5. Let me write the structure. Let us see how many get the correct answer. SO4 2 minus 6/4, that is 3/2, 1.5. Yes, correct it is. Good, good, very good. Yes, Naveed, correct. Gaming YT, change your name, yeah. Keep your name normal, student name. Shranya, good. So resonance we have done, and as per NCRT only we have done. We have not done the multiple cases of writing the structures. Why? Here it is not given. So we are focusing on the theoretical point and explanation which is given for CO2 and carbonate. Bond lengths Y equal because of resonance effect. ठीक है? So any question from your side up to resonance? Up to resonance, any question you want to ask? And I hope that you got the material also by this time. You got the material or not? Means you have arranged the material or not? You got the material so that you are trying the questions of the module. Answer is coming no. What's the no? Yaar? How it is possible? No, no, no. Achha, Sukanya got it. Very good, Sukanya. Other students also, bhai. What about the status of module? Swati got the material. Sela Kavita, no. Vagdevi, very good. Last year material has changed, na? Exercise changed, questions which are more relevant, they are added. Always take the fresh material. Arey bhai, when you are starting from the beginning, Hari Surya, when you are starting from the beginning, now you are starting from the scratch again. So why you want the same material? Slight variations are there. Exercises, I think, changed. Organic, so I have seen that is exercise 1, 2, 3 there. Or questions are, some questions removed also. Every one of you, try understand one thing. If you have taken a decision that yeah, this year I will give for complete preparation, then every aspect you have to prepare with the classroom notes, with NCRT, with module. If new is there, upgraded one is there, go for it. Do not think about this that okay, it's a waste of money. No, why? Whenever time is there, na, because you all are same students who have the material, we can discuss questions in class also, and that is important part. That any question is there, you can say, I can say, okay, this page number, yes, this page number, go for it. Otherwise, so you mismatch. You will not even feel that okay, which page number it is, I am not getting this question. So once you are attached, go for it completely. ठीक है? Do not think that okay, I'll save some money. Arey yaar, when you have going for it, go for it completely. Whatever given, it is only for your good, and you will only practice better. Practice gym, okay, yeah, practice gym material only. So many materials in the market, so many books in the market you will get. No need to waste your money on the books. Why? They mix JEE mains content there. They mix JEE content there. What happens? You are going to find difficulty because so many concepts beyond NCERT. So many concepts not required now in P block you will do. What's the use of those material? ठीक है? Now Blessy asked one question, page 110, right para. यार 110 पेज नंबर में right para में which point? First point, resonance stabilizes the molecule. This one है ना? In this point, if you observe, resonance means electrons are going to be revolving or continuously delocalizing. So what happened? Resonance stabilizes the molecule as the energy of the hybrid. Hybrid is always more stable. Hybrid is always more stable. So what it means? That always the energy of hybrid is less than any of the theoretically written structures which are resonating structures or canonical structures. ठीक है? Board brightness is more. I'll change that one. You can check, read your NCERT book, na? Sukanya, read your NCERT book, page number 110. Read your book, do not see that time. Because that person, technical person is not here. I have to tell him. Yaar, bold brightness. Brightness less. Prasad ji, paper in the group not given. Online group. That has to be clear. Now it is fine. It is now, see that. Blessy, read the last class notes. Some point we have discussed. Some points we have discussed that resonance points are there. Na? So hybrid is always more stable than any of the resonating structure because that is the actual molecule and which is more stable, always less in energy. So last class notes you have to read. Last class notes you have to read. That point is similar given here. ठीक है? Students are saying blur, it is blur. I think now fine. Yes, okay. They are saying blur. Let me write something. ठीक है, going back to the. Any other question from resonance? Any other question from the resonance part? Any questions? नहीं है? Okay, then I am going for the next concept. Next concept is molecular orbital theory. Now it is clear. Now it is fine. Everyone just check it. This is fine now. No problem in reading. ठीक है, done. सही है. Okay, now students, we are talking about new concept. What's the new concept is, which is next model in covalent bonding is molecular orbital theory. If you remember, we have talked about O2 molecule in VBT, which is 2p orbital overlap. As per VBT or Lewis structure, we can never prove that why O2 is paramagnetic in nature. ठीक है? But by using this model, which is MOT, we have written the configuration and then decided yes, it is paramagnetic in nature. So these are some points related to MOT scientist name given, Hund and the Mulliken. What are the key points of this one? What are the key points of molecular orbital theory? Okay. First, we know that electrons in the atomic orbitals or electrons in atom are present where in the atomic orbital. Similarly, electron in molecules is present in molecular orbital. That is what given here. ठीक है, first point, electrons in atom is present in atomic orbital. So when molecule is formed, that electron will be present in the molecular orbital form. Atomic orbitals of comparable energies and proper symmetry, they should combine to form molecular orbitals, because we are talking about now molecules. So molecules are formed by the atoms are combining, and these atomic orbitals are combining, resulting into new orbitals which are molecular orbitals. So which atomic orbitals should combine? Which have proper energies and they have proper symmetry, or similar energies and proper symmetry. Electron in atomic orbital is under the influence of a nucleus, single nucleus, yes, but electrons in the molecules, they are under the influence of more than one nucleus, because in molecule we know it's a combination of atoms. So what is the point? Electron in atomic orbital influenced by one nucleus, whereas electrons in molecular orbital, they are influenced by more than one nuclei. So we can say that atomic orbitals are monocentric, whereas molecular orbitals are polocentric. So you can underline this line also. Atomic orbitals have one nucleus, that's why it is monocentric. In molecular orbitals, there are more than one nuclei present, hence it is polycentric in nature. Then next point is, always whatever is the number of molecular orbital formed, it is equal to the atomic orbitals combined. Suppose 3 atomic orbitals combining, so 3 molecular orbitals will be formed. 2 combining, 2 will be formed. And one will become bonding molecular orbital, more stable and less in energy. Other will be termed as anti-bonding molecular orbital, which is higher in energy and less stable. So whenever atomic orbitals combine, molecular orbitals will be formed. Half of them will be bonding molecular orbital, more stable, and half of them will be anti-bonding, less stable molecular orbitals. This is the point given. Bonding molecular orbital has lower energy and hence greater stability as compared to which one? Anti-bonding molecular orbital. Why? Because in bonding molecular orbital, what happens? Electron density increases between the two nucleuses. Whereas in anti-bonding, what happens? Due to destructive interference, electron density between the nucleus decrease and hence repulsion factor more. So in short, bonding molecular orbital BMO is more stable than ABMO, anti-bonding molecular orbital. Then here, these are the postulates. Electron probability, just as electron probability distribution around the nucleus in an atom is given by atomic orbital. This term you have, or you might have done in the Schrödinger model also. That is, the electron probability distribution around the nucleus is given by atomic orbital, or the atomic orbitals tells us about the maximum probability of finding the electron. Similarly, electron probability distribution around the group of nuclei in a molecule is given by molecular orbital. Nothing new point, but you will read every point and you can add in the notes also. But reading is must. Every time when you go through, you have to go through the points. Then molecular orbitals are filled according to which principle? Above principle, Pauli's exclusion principle, and Hund's rule. So these are the salient features, or we can say postulates of which one? These are the postulates of molecular orbital theory. Clear? So now you can write these points also, starting with the MOT. Molecular orbital theory, its important features are there. or key points of this theory. ठीक है? Now write down the first point. First point is, as electrons in atoms, write down first point, as electrons in atoms is present in, as electrons in atoms are present in atomic orbitals, present in atomic orbitals, present in atomic orbitals. Similarly, electron in molecules are present in MO, molecular orbitals. Similarly, electron in molecules are present in MO. Short form you can write molecular orbital it is. Next point, atomic orbital is monocentric. Atomic orbital is monocentric, whereas molecular orbitals are polycentric. Whereas molecular orbital MO are polycentric. Molecular orbitals are polycentric. Next point, atomic orbitals AO, atomic orbitals combine linearly. Atomic orbitals combine linearly to form molecular orbitals MO, to form molecular orbitals, and number of atomic orbitals combine is equal to number of molecular orbitals formed, is equal to number of molecular orbitals formed, is equal to number of MO formed. Next point, two atomic orbitals combine to form two molecular orbitals, one is bonding molecular orbital BMO, short form you can say in bracket BMO, bonding molecular orbital, which is more stable, and less in energy, than the combining atomic orbitals AO, and less in energy than the combining atomic orbitals, whereas other is anti-bonding MO, molecular orbital, whereas other is anti-bonding molecular orbital, ABMO, having more energy than the combining atomic orbitals, having more in energy than the combining AO, atomic orbitals. ठीक है, next point is, last point is electrons in molecular orbitals. Electrons in molecular orbitals is filled according to Aufbau rule, Hund's rule, and Pauli's exclusion principle. By which way we will fill? As per them only. Aufbau rule, Hund's rule, and Pauli's exclusion principle. Pauli's exclusion principle. So these are the points, key points or salient features of molecular orbital theory. Just read them. Already in NCERT I have gone through it. But still you read NCERT after the class. Right now read from the notes and find out it is any question you want to ask among them. Completed reading? Any point you want to ask? Any key point? Chandra, I will talk it about later on. Okay? Now only content, only academics part, MOT theory. Third point is that whenever the atomic orbitals combine, that is the point. Third point is atomic orbitals combine linearly. Actually, this point you will get after reading the NCERT, that whenever we are saying molecular orbitals are formed, so one method is given there, LCAO, linear combination of atomic orbitals. So when you read further, you will get that one, that atomic orbitals combine linearly. Linearly, what is given? That addition of orbitals or addition of the wave function and subtraction of the wave function. That is the meaning of linearly. The atomic orbitals combine linearly, means psi A plus psi B or psi A minus psi B. Then what is formed? Bonding molecular orbital and anti-bonding molecular orbital. Getting it, Vijay? So while you read that one, that term is used, that linearly they are combining. Linearly means addition of the wave function and subtraction. Okay, now after this, what is given there? After these features, next part is given with LCAO. How it is formed? By which method? LCAO. This is linear combination of atomic orbitals, in which you will read it after the class. Somewhat you get the idea from the atomic portion, and in the notes we will write it, key points as per our requirement. Here it is given psi A psi B means atom A atom B, and here it is given mathematically. How it is described? Mathematically like this one. Formation of MO described by the linear combination of atomic orbitals takes place by addition as well as subtraction of the wave function. So that is the portion given. Psi A plus minus psi B. Plus will be bonding and minus will be anti-bonding. That portion you will understand easily once you read it. Then diagrams we will talk about later on. Then terms are used from the physics: constructive interference and destructive interference. That part I will explain. But you will be familiar which part you have to read after the class. You will read complete this paragraph. Getting it? You will not skip this paragraph up to this part, which is explanation of given of psi A or bonding and anti-bonding molecular orbital. You will not leave that one. Okay, so now in the notes, we'll talk about this one. Okay. Now after this point, you can mention in the notes. Mention here molecular orbitals. 1 or 2 lines you can leave. You can mention molecular orbitals are formed by. Molecular orbitals are formed by linear combination of atomic orbitals. Molecular orbitals are formed by linear combination of atomic orbitals. Linear combination of atomic orbitals. Suppose what is there? There are 2 atoms given. Hydrogen given there, A, and other one considered to be B. Then with atom A, its wave function will be psi A. And for atom B, its wave function will be psi B. Okay? These are the sign of the these are the wave functions. For one is for atom A, other is for atom B. Now what is given in NCERT there? They are combining. Okay? Atom A are this one. A has atomic orbital A, it has B. So we can use this term, and then psi of molecular orbital. Now it is fine, students. Check it.
Yes, check.
Now it is fine. हाँ, coming.
Light off.
नहीं तो अचानक से कैसे हो गया ये? इसकी बैटरी कम तो नहीं है उसकी?
नहीं
हैं? फिर सडनली कैसे स्टॉप? रेड लाइट
आ रहा है ना?
रेड लाइट आ रहा है. हाँ, रेड लाइट.
White light आना है ना?
Here red light coming above. Seeing?
Yes.
रेड लाइट बैटरी गई इसकी ना?
अभी तो आ रहा है.
आ रहा है?
मैं इसको चेंज करूँगा.
दिख ही नहीं रहा यार. वहाँ पर लाइन आउट पे रेड ला रहा है.
नहीं आप अभी तो आ रहा है, चेक कर लो।
हाँ आ रहा है, देखते हैं ना इसको।
व्हाइट लाइट आ रहा है
बैटरी दिखी नहीं मुझे यार।
ऊपर।
पता नहीं है कि नहीं, चेयर वो नहीं, उसके ऊपर देख लेते हैं ना।
इधर तो व्हाइट लाइट भी आ रहा है ना, ये बंद हो गया।
तो
White
बंद
light
बंद
आना है।
व्हाइट आएगा, इस रेड से
हाँ,
कुछ भी दिक्कत नहीं
हाँ,
है।
नहीं।
ठीक है ठीक है ठीक है ठीक है। So here you can see it is the molecular orbital is formed by the linear combination in which one will be bonding I think now it's working.
Yes.
Students, am I audible?
Dolby sound आ रहा है बोल बोल.
Dolby sound. Yes, yes. Finally, yes, yes, started.
Yeah.
So luckily, within this time, it worked.
सार क्लास है ये.
Chalo. So we were discussing about that the atomic orbitals are combining linearly. Atomic orbitals combining linearly means addition of the wave function and subtraction of the wave function. And two atoms are there with atomic orbital A and B. That is psi A and psi B. Okay? So what is written in NCERT? That psi MO, that is the wave function of the molecular orbital, is psi A plus minus psi B, in which bonding molecular orbital psi A plus psi B, addition of the wave function. Second one is psi ABMO, which is psi A minus psi B. Okay? Now here, which is psi BMO. Psi BMO or bonding molecular orbital, it is found by which interference? It is found by constructive interference. It is formed by constructive interference. It is formed by which way? By the constructive interference, in which what will happen? The electron density increases in the region between the two nuclei. So mention this line. It is formed by constructive interference. The electron density increase in the region between two nuclei. So what will happen because of bonding molecular orbital? It is formed by the constructive interference of the atomic orbitals, and what happens because of that? Due to bonding molecular orbital, the electron density increased between the region where between the two nuclei the electron density increases, and when electron density increases between the two nuclei, stability increases. Hence, stability increased, because there will be more attraction between the two nucleus. If more density is there, it is better, that leads to attraction. If less density will be there, then nucleus will repel, and that leads to anti-bonding. So psi BMO is formed by the constructive interference, and this increases the electron density in the region between the two nuclei, hence stability increases. It may or may not have nodal plane. That when BMO is formed, they may contain nodal planes, they may not contain. That structures are given, that we will discuss combiningly when BMO and ABMO are drawn. So when they combine, it can be shown in this manner also. So that is how we can represent it. Psi A, psi B, constructive interference taking place, crest with crest, trough with trough. Psi A plus psi B. Okay, this point clear? Then similarly, you can mention about psi ABMO. Write down about psi ABMO. It is formed by the destructive interference. It is formed by the destructive interference. It is formed by the destructive interference. Second point, it decreases electron density. Same point you can change. It decreases electron density in the region between two nuclei. It decreases electron density in the region between two nuclei. Between two nuclei. Hence, repulsion increases. Hence, repulsion increases. Hence, repulsion increases, stability decreases. Stability decreases. Stability decreases. Now tell wave downwards. Shania, what happened? Wave starts at downwards. This is combining with this one. If I say, if it is written in this manner, then you will understand also easily, that is, it is a constructive interference taking place. ठीक है? अच्छा, in anti-bonding you are saying, okay, this point clear? So in anti-bonding we can show it like this also. In anti-bonding we can show it like this. This is psi A, and other one will be in this manner, which is like this. One will be psi A, one other will be psi B. And when they combine, finally some smaller part of the wave function can be shown. This will be psi A B M O. Psi A minus psi B. ठीक है, that is the representation for ABMO, anti-bonding molecular orbital, in which what is taking place? Destructive interference. And why this leads to less stability or more energy? Because electron density is reduced between the two nuclei. When electron density is reduced, there will not be attraction, there will be internuclear repulsions. Therefore, anti-bonding means high energy, less stability. And then you can mention it always contains, or it always has nodal plane or nodes. It always has nodal planes or nodes. आई बात समझ में? It is about bonding and anti-bonding molecular orbitals. How it is generated? They are combined, or they are formed when the atomic orbitals combine linearly. Linearly means addition and subtraction. Psi A plus psi B. ठीक है? Up to this point clear? Then next part when you read it, some conditions are given. So that you can directly add. That part you will read, and then this part, conditions for the combination. This part you will add in the notes. Okay, that part I will maybe dictating, or you can directly add. What are the conditions for the combination of atomic orbitals? First is, which orbitals always combine? Those have similar energy. So these are important points for statement type. Combining orbitals must have the same or nearly same energy. Which example given? 1s will combine with 1s, first shell, not with 2s. Okay, so you can understand easily this point. Combining atomic orbitals must have same symmetry. Remember the symmetry we have talked about. px with px, py with py, like this, but they should not be px with py. That is the point, that the orientation or symmetry should be proper of the atomic orbitals which are combining. 2 points. Second point is done. Third point, the combining atomic orbitals must overlap to the maximum extent. We know as extent of overlap increases, strength of bond is better. So that is the point. The combining orbitals should overlap to the maximum extent. That leads to more stability of the bond. Clear this point? Up to this clear? We have done what? Just we have done the features of the model. Then important part, linear combination of atomic orbital, meaning, ठीक है? Then other point is conditions for combination of molecular orbitals. You have to add these points. Example you understand, but add these 3 points. Bolo, till this point clear? In next class we will talk about the diagrams and molecular orbital theory configuration. So it will be better to start in the next class in which diagrams has to be drawn. Okay. Done. Any other questions you want to ask? Any questions from your side? Okay. Then we will meet in the next lecture with the MOT further. QR code. Okay. Today nothing more is done. What you will copy from that? Best is from the YouTube. You can see that one. ठीक है. Okay, students, take care. We'll meet in the next lecture. Till that time, you can revise, you can do the paper analysis, identify your mistakes, work on the mistakes. Okay, bye.